Hello, everybody. Welcome to the last part of Geos 120, Geos 119. And in this part, we'll talk mainly about glaciers. So far, I've been covering volcanoes and earthquakes. So now it is time for the frozen part of Alaska. My name is Victor. I'm Victor Devaux-Chupin. I'm a PhD student here at UAF. And I'd be happy to guide you through the nice things that you can find in Alaska that are glaciers. Just as a quickly, I'm trying to stick to how the other instructors were running their parts, but there are still some differences. If you're lost in any way, don't hesitate to reach out to me either through Canvas or email, or to reach one of your TAs, and we'll be more than happy to help you navigate in that. So this first lecture will be split into different sections. And it will mainly focus on where to find glaciers and what they mean to us as a society. It's a bit broad, but eventually by the end of it, you should have a better idea about what glaciers are. So I'm going to start with just saying a few words about myself. I'm a French PhD student here at UAF, arrived in Alaska in the middle of winter 2020, in the middle of the pandemic. Amazing time to come to Alaska. If my accent is horrible, please let me know, and I will try to make an effort, especially if you can't understand anything that I'm saying. That eventually is an issue. So yeah, let me know, and then I'll try to improve that. Yeah, here is me standing on a rock glacier in McCarthy, Alaska. I'm talking about that because it's actually always a really cool field work where we were trying geophysical methods. So by geophysical, I mean methods to study the surface of the Earth, and we were trying to see how well we could detect water beneath those rocks. This is a rock glacier, so it's composed of many rocks, and in between those rocks and below those rocks, there's some ice. And NASA was interested in that because eventually the techniques we were trying, they would use some of them potentially in the future on Mars and other planetary exploration. So pretty amazing field work. That's the closest I was to realizing my dream of being an astronaut. And yeah, one important thing, please fill that poll here. You have the link, you can type it on your web browser. It's just a link to give me an idea about, if you're enjoying the course, if you find it hard or easy, where you are in Alaska or in the US, just to give me the occasion to know a bit more about yourself. Another thing that I should cover is that the assignments are the same. You still have that weekly assignment and some quizzes coming along during that part of the course, and you will still have the training quizzes related to each section of the lectures. So this slide has a lot of things on it, but basically during this lecture, we'll see where glaciers are found, how they can appear on this planet, what types of glaciers there are out there, because they come in many different shapes and forms, but also how much each of them might contribute to sea level rise in our context of global warming, and what that represents to us as a society. Really meta. So what are glaciers? Glaciers are masses of ice that are made from snow. So usually you have a glacier that's sitting on a mountain, snow that's falling down on it. I hope you can see my mouse on the screen, by the way. And so as snow falls in the mountains, if it doesn't melt away, it accumulates. And after a few years, this snow will slowly transform into solid ice. And if you have a big amount of ice, eventually at some point, it flows downhill. Gravity pulls it down, and you basically have a glacier. So glaciers are masses of ice that deforms under their own weight. They build up over several years, and you can find them mainly in the mountains, but not always, because there are very specific factors that allow for the formation of glaciers, and we'll cover that a bit later. So this is the general definition of a glacier, and also the last slide of this section. a glacier is a mass of snow, firn, and ice that moves under its own weight due to gravity. That's very important because sometimes you can have sitting ice somewhere that doesn't move, that doesn't flow at all. Usually, that's kind of what awaits a glacier that's dying. Let's say, for example, this is our glacier and it's retreating with warming climate, and eventually you only have like a patch of ice up there in the mountain. If it doesn't move, if it doesn't do anything aside from melting away, we stop considering that as a glacier, because glaciers have this movement component that is very important. If glaciers were static, that would be much easier for us to study them. But there's a very interesting thing, is that we are talking about a solid, the ice, that flows like a liquid. But it's not like a liquid like water. A good comparison, for example, would be pouring honey on a table. Honey is very viscous, and you can see the deformation much better than with water. Or you can think about molasses that are, I don't know, sliding downhill. That is what a glacier kind of looks like if you accelerate the time scale, and on long time scale, sorry. So yeah, that is the definition of a glacier. Don't learn that word by word, but the important thing is that it's made of snow, firn, and ice. We'll explain the firn component later. And it moves under its own weight, hence gravity.